All right, hello everyone. Welcome to Unit 3, Lessons 6 and 7. And this is involving squares and square roots and inequivalent equations. Okay, one of the big things that we have looked at in the past, throughout some of our past units, is equations that we have to solve using a square root. And so we had an equation like, say, x squared equals 16. We had to figure out what x is, right? So we're going to be studying equations like this and the difference between squares and square roots and how we can handle functions that involve one or both of those operations. So let's start off with kind of what we know and what we can picture going forward. All right, activity number 1, 4 squares. Let's find the solutions to some of these. All right, x squared equals 4. All right, now we have a picture of the graph, and clearly you probably also think about like what numbers you would square, and that would give you a value of 4. And, 2 definitely, right? 2 squared is equal to 4. But also, if you look at the graph here, not only does 2 work, but negative 2 also works. And so usually we represent that with a plus or minus sign, right? And that's because 2 or negative 2, when you square them, you get an answer of 4. Both answers are correct in that way. What about x squared equals 2? Well, if x squared equals 2, it looks like those points here, and it looks like that's a point here too. So that looks to be a little bit less than 1.5. And it turns out we could just say x equals plus or minus the square root of 2. And you might remember doing that in our quadratic unit. And that's about 1.41. So a little bit less than 1.5. But again, you get a plus sign and a minus sign because whether you take the positive root or whether you take a negative root 2, you square both of those, and negative times negative is positive. So therefore, both answers work. What if x is 0? Well, if x is 0, well, again, let's see, we can take the square root of both sides. So x equals plus or minus 0. Well, can there really be a minus 0? No, 0 is neither positive nor negative. Therefore, a negative 0 is, well, negative 1 times 0, and that's still 0. So multiplying by a negative doesn't make it negative. Therefore, we just get the single answer, x equals 0. And then finally, what about x squared equals negative 1? Well, if x squared equals negative 1, here's my parabola, here's my negative 1 line, the two never cross. There's no solution, there's no number that we can multiply by itself that gives us negative 1. I should say no real number. And therefore, like 1 times 1 is 1, negative 1 times negative 1, still 1. The only way to get negative 1 is if you had one negative and one positive, but that's not squaring, right? So there's no solution there. There's no number when squared produces a negative, and that's important for the work that we're going to do here. Because that means that some of these answers have solutions. Some have 2, some have 1 solution, some have no solutions. Okay, so what's this one? What does root 4 plus root 9 equal? Okay. Well, let's see. Could it be? Well, let's see. Square root of 4 is 2, right? Square root of 4 is 2. Square root of 9 is 3. Maybe 2 plus 3 equals 5? Could be. But also, root 4 plus root 9, well, 4 plus 9 is 13. So perhaps it's the square root of 13? Well, one of these answers has to be correct, right? So it's either going to be root 13 or it's going to be 5. And those two are not equivalent. Well, what does our calculator say for this one? So let's turn on the calculator and let's try it out. We're going to do root 4 plus root 13. Oh, sorry, whoopsie, wrong numbers. Root 4 plus root 9. Root 4 plus root 9. 5. Okay, so the answer appears to be 5. So it looks like the 5 is correct. And it kind of makes sense too. Square root of 4 can simplify. Square root of 9 simplifies. And here's the other thing to think about. Think of the order of operations, right? In the order of operations, PEMDAS, right? What comes first? Parentheses? No parentheses. Exponents. Multiplication, division, addition, subtraction. But square root. What operation is that? That's not in PEMDAS, is it? Ah, but it is, because don't forget that root 4 can be written as 4 to the 1/2 power, thanks to the work that we did back in lessons 1 through 5, plus 9 to the 1/2. So those are definitely exponents, and the exponents would happen before the addition does. Therefore, we got an answer of 5. Therefore, unfortunately, that's not wrong. So never ever add radicals, okay? Always simplify radicals before adding. Now you can multiply them. That turns out that's a okay operation to do. Like if we did root 4 times root 9, that would be root 36. And that's because with that, you can rearrange the order of the exponents. Okay. So what about cubing? Now we've done a lot of work with squaring, right? Squares, square roots. We haven't talked a lot about cubes and cube roots until this unit here. So let's think about this. Okay, x to the third equals 8. Okay, what number to the third power gives us 8? X equals 2, right? We know 2 is the obvious solution. Now, negative 2 should also be a solution, right? But wait a second. Negative 2 times negative 2 times negative 2 is negative 8. Only 2 is a solution to that. Therefore, there's only one solution. If that were x squared equals 8, there'd be 2 solutions. But x to the third, one solution. Interesting. Now, what about this one? Y to the third equals negative 1. Okay. Now, again, if this were a square root problem, we'd say, can't be done. Can't take the square root of something and have it be negative, right? What times what would give you a negative 1? We've already shown that that's no solution. But to the third, negative 1 times negative 1 times negative 1 is in fact negative 1. So x does equal negative 1 here. And we get one solution. So cubing does allow for negatives. Okay. So if square root, no negatives. Cube roots, negatives allowed. What about a fourth power? What to the fourth power gives you 16? 2 does. So z equals 2. Oh, and I meant to say y on that one. That's okay. So z equals 2. Okay, let's check negative 2. Negative 2 times negative 2 times negative 2 times negative 2. That does get you a positive 16 because the negatives will pair together to create a positive. So you do get a 2 solution again. So with a power of 4, we go back to the way the square root works. And we do, in fact, get the 2 possibilities, 2 or negative 2. Okay, so then what happens when we get to negatives? So 3 times 3 times 3 times 3 is 81. Negative 3 times negative 3 times negative 3 times negative 3, that will still be positive because, again, the negative signs pair together. So W has, again, no solution because of the even number of negative signs. And that becomes a very generalized rule. So now let's write out what's happening. Clearly, there's a difference between having an even number of negative signs and an odd number. And that, in turn, comes from the exponent. So when you have an equation of this form, x to the n equals n, if n is even, then if m is greater than 0, 2 solutions. If m is equal to 0, 1 solution, and usually that's a 0. And if m is less than 0, no solutions. And that's because you cannot have an even power come out to a negative answer. I probably could have typed that a little bit better than writing it, but, I have it written down there. Hope that's easy enough to follow. If n is odd. Now, in this particular case, it's pretty similar, but we only really have the difference at 0. In all cases, of n, 1 solution. And the reason for that is because this will give up one of its solutions, so that being negative will pick up a solution. No matter whether m is positive or negative or 0, you'll always be able to take a cube root, 5th root, 7th root, 9th root, and it comes out to exactly 1 answer. And that's important to realize. Okay, so now let's think about the actual operation of root itself. Okay, so when we solve an equation of, say, let's say we have an equation d squared equals c, right? Or let's say we have the equation, x squared equals 25, right? We solve that for x, right? Or we take, let's not use 25. Let's make this a little bit clearer using, actually, no, we'll use 25. What is x? We take the square root of both sides, plus or minus the square root of 25. Now we happen to know that that's 5, right? I'm going to leave it as root 25 for just a second to kind of illustrate something here. So we know that there are 2 answers that work, the positive root 25 and the negative root 25. But in both cases, the sign is it's outside the radical. When we take the square root, it's either going to be the positive root of 25 or negative root 25. Now, what does a negative sign mean? A negative sign represents a multiplication by negative 1. So if I say, negative 5, and a calculator does this. If you type negative 5 into the calculator, what it's actually doing is it's doing negative 1 times positive 5. That is the inherent definition of a negative sign. So that 5 itself is considered a positive quantity. So if you look at this radical here, when we put a plus or minus sign in front of a radical, the minus sign represents a multiplication by -1. The root part itself is considered positive. We don't assign two potential values to the same quantity because the reason for it is, you might remember this from Algebra 1, is you don't want a function to have two potential answers because how would you know at any given time which one you needed? Whether you needed a positive root or a negative root. So for that reason, we don't say that square root of 25 is either 5 or -5. But what we do is we keep the root 25 as positive, and we allow potentially a multiplication by -1. So what we then do is we then say the square root of 25 by itself is 5. End of story. However, again, do understand the difference of what I'm trying to say here. So what this then, consequence of this is when we say square root of 25, yes, the answer is 5. And so again, already here. So the square root of, according to this graph, and you can see right here, square root of 25 is equal to 5. And just plain 5, not -5, not anything else. Square root of 25 is 5. Keep in mind that when we solve this equation then, why do we say that we get two answers? It's because in this equation, we're using a square root in order to explain something that's being squared. But at the end of the day, this equation, the main operation is squaring. Oops, not square root. So the reason why we have two solutions is because both of them, when squared, does give you 25. Even though the square root of 25 itself is only 5. I hope that makes kind of sense there. So root x means the positive square root of x all the time. And we can illustrate the negative by sticking the negative sign in front of it. And remember what we said before, too. Remember that root x is equal to x to the 1/2 power, and we even said that raising numbers to powers does not produce negative answers. There you go. Okay. So, same idea here, right? Again, we have x squared equals 4. We take the square root of both sides, and we get x equals 2. So again, in this case, when you apply a square root to solve an equation, the square root is just meant to uncover what x is, but the operation that's going on is squaring, right? And so it turns out, in this case, we are allowed to say -2 because -2, when squared, does give you 4, right? So again, so there is definitely a difference in the situation there. The rest of our lesson is going to involve equations that start with a square root rather than starting with a square. In those cases, then yes, we have to only consider the positive aspect of it. So let's take a look. Let's say we have the equation root x minus 1 equals 3. She said, well, this person, Jenna, she says, I can square both sides of the equation. Perfect. Okay, so she does. So the square undoes the square root, yes. Then you get a 3 squared. X minus 1 equals 9. X equals 10. Does the solution work? Well, just plug it in, right? Oops. Whoa, hello. That was unique. I pushed too many buttons. Plug it in. And sure enough, does 10 work? Let's see. 10 minus 1, that's square root of 9. Square root of 9 equals 3. It checks out. Perfect. Okay, what about this one? Square root of x minus 1 equals negative 3. You might already be able to tell that, like, didn't we just say that roots can't be negative? Yeah. Because here's the problem. You can still solve it, right? Because, I mean, you could square both sides, but then you get x minus 1 equals negative 3 times negative 3 is 9. You add the 1, and you still get x equals 10. And if you plug it in, you get the case of, square root of 9 equals negative 3. We're trying to avoid that situation. And so we're trying to say the square root of 9 is intended to be a positive answer. Therefore, we're not going to accept that. So, moral of the story here, in this particular case, and I'll try to, illustrate this a bit better, okay, is that, square roots of expressions and of expressions of any algebraic construct, really, should not equal a negative. If it does, the equation won't have a solution. So the first one had a solution because the root equaled a positive number. Here, a root equals a negative number, so it won't have a solution. And that's really kind of the meat of this, right? Okay, so let's solve a few equations. So root t plus 4 equals 3. Okay, now we can square both sides. I do like to illustrate the parentheses around each individual side. Some people like to do this and take both sides like this and square. I don't like that because it can be hard to see like how many terms in each side that you're actually squaring and what you actually have to multiply, because sometimes you need distribution to handle those. So I don't like doing it that way. I like squaring both sides individually like this. And so here, it's pretty clear that root square cancel out. T plus 4 equals 9. Subtract 4, t equals 5. Does that work? You bet. Plug it in, root 9 equals 3. Awesome. Okay, what about this one? So in this particular case, we have, so negative 10 equals negative root a. Okay, negatives. But we said that root can't be negative. Oh, look, this side also has a negative. I can divide out the negative one to start. Or simply you could cross out the negatives because they just cancel out, right? And you get 10 equals root a. Will I have a solution? I bet. Square both sides. 100 equals a. Okay, number 3. So here's an interesting situation. You have a root and a number where that radical bar does not extend over the minus 4. How would we solve this? Start note. Isolate the radical term. You always want to isolate the radical term. Add the 4 to both sides. The reason is you only want to square the radical piece. So you can square whatever's on the other side, it's fine. But you want the radical to be isolated so that the square only cancels out with the radical. If you don't, I'll explain what's going to happen in a little bit. Let's add the 4. Now we square both sides. 3 minus w equals 16. We can subtract the 3 from both sides. And so w equals negative 13. Okay, so here's my question. Did I have to subtract, or sorry, add the 4 to both sides? A lot of people might consider, oh, let's just square everything right away. You get a 3 minus w, you get a 16? But is it a positive 16 or a negative 16? Ah, it would be a positive 16, yes, because you can change that to plus a negative 4. But here's the other problem with this. And I'm going to illustrate this by a slightly different color. So I'm going to back this out and change the color a little bit. Change the color. Okay, so what would happen if I actually squared both sides right here and now, rather than adding the 4 to both sides? How bad would that be? Well, here's the thing. Let's replace this radical with some letter. Let's call it r, okay? I'm going to take that and I'm going to replace it with an r. And I'm going to say that r represents this radical, just so that I don't have to write root 3 minus w again, okay? So watch what happens. I'm going to rewrite this equation, but instead I'm going to have r here. So I'm going to have r minus 4 equals 0. Okay? Now I'm going to square both sides. But guess what? I'm going to square both sides. Yeah, I'm going to get a 0 over here, but what's this? I have to distribute that. And I'm going to get r squared. And it's going to have to be written out as a trinomial. I'm going to actually have to do r minus 4 times r minus 4 and distribute that. That's a problem. But I tell you what, why don't you hang on to the end of this video? At the end of this video, I won't do it here, but at the end, I will go back and I will actually do this out with what happens if I attempt to do this. Spoiler alert, it is a way, way, way harder problem to do that. And I suggest you don't do it. But if you're curious as to what happens if you square both sides when you have both a radical and a number, it is a mess. And it is a big mess. And I will show you how big of a mess it gets. So hang on to the end of this video. But that's not necessarily part of the main lesson. What is part of the main lesson is isolate the radical. Add the 4 to both sides, and then when you square it, no mess. Nice and clean. Same thing over here. Subtract 9 from both sides. Root z equals negative 9. Hey, we know this one. Guess what's going to happen? Nothing. Why? Because roots can't be negative. Okay. And so here's just a little bit of the, we kind of covered that image already. Okay. Beautiful job. All right. Hey, you know what? You've reached the end of the video. That was pretty easy. So tell you what, let's actually now go back and fill in some of those problems. So let's go back and check that expression out. I told you at the end of the video I would do this. Now is a perfect time. So let's do it. It was, what was the expression again? It was something, oh, minus w. It was 3 minus w. 3 minus w as a square root minus 4 equals 0. Okay, and so what we want to do is see what happens when we actually square both sides and show you how much of a mess this is. Because why not? I like math. And it never hurts to see it, and maybe you'll be scared enough to actually see all this written out that maybe you won't do this. Okay, so here's what happens. Like we said before, if we replace that with an r, we get r minus 4 equals 0. We're going to square both sides. I'm going to take this out of full screen so I can mess around with the colors. Okay. So what happens when I multiply this out? I get r minus 4 times r minus 4. I get r squared minus 4r minus 4r, so minus 8r plus 16. And 0 squared is 0. So what is that going to look over here? I'm going to get the radical piece squared, so I'm going to get 3 minus w minus 8 root 3 minus w plus 16 equals 0. Okay. Notice we squared both sides and the radical's still there. That's part of the issue that we have here. Yes, one side had disappeared, a more radical term popped up. So am I going to have to ultimately square both sides again? Yes. So now what we have to do is we have to isolate the radical part again and then square the equation again. So to do that, I have a positive 3, I have a positive 16. So I'm going to subtract 19 from both sides. Minus w minus 8 root 3 minus w equals negative 19. Add the w to both sides. I could do plus w, so I'm going to just do this as w minus 19, because I have to add the w to both sides. So we get negative 8 times root 3 minus w equals w minus 19. Now, at this point, I could divide both sides by negative 8 to isolate the radical. But what that would do is leave me with a fraction mess over here. And I am going to have to square both sides. So rather than leave the fraction mess, I'm actually going to square it right now. Again, even though I've got a number that's not totally isolated, but remember that in a multiplication problem, I can square both sides. And this is the product, this is the power of a product property that does this. So what I end up with is 64 times 3 minus w equals w squared minus 38w plus 19 blah blah blah, 361. Oh boy. All right, let's combine our terms, right? So 64 times 3 is 192 minus 64w equals w squared minus 38w plus 361. Oh my goodness. Okay. All right. I'm going to rely on a calculator now. So, let's see. 361 minus 192. Oh, just subtract 200 and add 8. So 169? Perfect, 169. Hey, that's a perfect square of 13. Good to know. And then finally, we're going to add 64 to both sides. So 64 minus 38 is 26. W squared. We get 0 equals w squared plus 26w plus 69. 169. So it turns out 169 is a perfect square. It's 13 times 13. Hey, that adds to 26. So guess what? This factors into w plus 13 squared. And so if 0 equals this, basically we take the square root of both sides and we get w plus 13 equals 0. And therefore, we get w equals negative 13. It worked, amazingly enough, and we didn't even get an extraneous solution from that. Wow. Okay. That was a lot of work to go through, though, wasn't it? Okay, just for that one problem. So, moral of the story, guys, please don't do this. Go back. I'm going to go back to this slide here. Isolate your radical terms. Make sure that before you square both sides, the radical piece is isolated on one side of the equation. You might have multiple terms on the other side, but never, at least for these, never any other radicals. Okay? All right, folks. I think that about covers it for this video. Keep practicing. Keep up the good work. I'll talk to you later.